So, hello everybody. I want to welcome you guys again to the NCGIS conference. This is our 11:30 presentation, and the title is Pipe Inventory, Condition Assessment, and Critical Analysis. My name is Elizabeth Daniel, and I'm going to be your moderator for this session. I did want to take care of a couple of housekeeping things before we actually turn it over to our two presenters, John and Corey. I will be monitoring the chat session, so just to let you know, attendees, you do need to actually join the chat. It should be opening now. So you can join that and feel free to send questions through the chat session. I'm going to be monitoring those, and around 11:50, we're going to open up 5 minutes for your questions, and I'll be relaying those to our two presenters. And I think that's pretty much it on my end, so I'm going to turn it over to John and Corey.
Okay, thank you. Yeah, welcome everybody. Thanks for sitting in on this session. My name is John Wisdom. I'm the GIS lead with SEPI Engineering in Raleigh. What we're going to be talking about today is a stormwater pipe inventory, condition assessment, and criticality analysis that we did with the Town of Edenton, the Department of Public Works in Edenton. Oops, sorry. If you're not familiar with Edenton, it's a small town in the northeastern part of the state. It's, as you can see from the photos, it's right on the water, only a 13-foot elevation above sea level. So as you might expect, stormwater system is a kind of a big deal. So it's critical for the town that stormwater system is in top shape, which is one of the reasons obviously we're working with Corey. I'm going to hand it over to Corey so he can introduce himself and give a little bit of background on the project and why they decided to go ahead with this. Corey?
All right, well, thank you, John. I did want to take a couple minutes just to kind of recap who I am and this project that we worked with SEPI on. So my name's Corey Gooden. I'm the Director of Public Works for the Town of Edenton. The Town of Edenton Public Works Department kind of houses 7 different divisions: water treatment, water distribution and sewer collection, wastewater treatment, streets, stormwater, sanitation, landscaping, as well as fleet maintenance. One of the big things that the town does is that we are really our customer service group, and we provide almost all utility services for the town except for electric. And one of the things that in the past few years that we've really struggled with is as the system, the stormwater system has become to near critical age. Kind of the life cycle of what we have here is drawn to an end. We started, having more recurring problems, and one of the issues that we came up with is that, we had maps and things that just were not as up to date. I mean, we had some things that were, 20 plus years old or even older. And what we found is most of our GIS data that we had been built around those files. So one of the things that we were challenged with is how can we kind of update the mapping system that we use for repairs and preventative maintenance, and also, how do we know just the overall condition of our system as a whole? Because things do change, where you usually don't have problems. New problems can rear their head, and this was something new for the town. Basically, taking these static maps and creating shape files was one thing, but actually surveying the data, the data points, and collecting that, we wanted to kind of thread the water, tread the water. So we started this project in 2 phases. We began with our kind of light residential zones to begin with, and more of a rural part of town. And once we got that data and just saw just how much we had, that's when we really honed in on our larger, more highly populated residential areas, as well as some of our businesses and our commercial areas, places that we knew would just take a lot more time. We worked on these projects over the last year. We're just now getting to our final report for our both phases, where that all be combined. And that's really why we started this way. And where we're unique at is by being so close to the waterfront. We had certain geographic, landscaping features that allowed us to be able to break the town up into zones. And these zones we knew had individual systems. And so this gave us an idea of how we could, kind of manage and group things to break this thing into 2 phases. Most of the time you ask yourself, well, where do you start? Well, you really start where these systems end, and you work your way back from that larger body of water back into, your last drop inlet, or your last yard inlet, or, your last, section of curb and gutter. And that's kind of how we, broke this project out. Oak Hill, Queen Anne, and Industrial Park were our phase 1. We knew we would have less data there, but we could at least get an idea of what kind of improvements we were going to see. And then after that, we focused in on our, heavy areas, our medical park, and kind of our historic district.
Okay, thanks, Corey. And so just moving on to the overview of what I'm going to talk about, project workflow. Obviously, one of the first things is develop a GIS data model, then move on to actually doing the field data collection, doing some QC, and then we generated some asset report cards and conducted a risk analysis. So for the data model, the photos on the screen are some examples. Show the feature classes that we developed in the geodatabase. So these are all parts of the stormwater system: drop inlets, pipes, manholes, ditches, junction boxes. So we developed these feature classes, and eventually they were put on ArcGIS Online. For each of those feature classes, we developed the different attributes, the schema for the fields that we needed to collect in the field. So you can see most of these are obviously condition based. You see different types of failures for the different assets, whether pipes or ditches are blocked, overall condition, that kind of thing. So we developed these based on SEPI's experience in doing pipe condition surveys, and also in consultation with Corey and his folks. And so one of the first things we did was obviously assemble our crew. Typically we had a 2-person crew going out. There's a 3rd person, which CJ Jackson, who was originally supposed to be one of our co-presenters, but he's got a newborn at home, so he couldn't make it. But he oversaw the field data collection efforts. So sometimes he would go out there with them. But these folks, they all have extensive experience with stormwater data collection. They have, local knowledge. CJ lives there. That kind of thing is really important for this kind of project, because there's not all of these stormwater features are obvious. A lot of the pipes are buried, sometimes they're overgrown, and you may not know that something's there, even if it's on some of the previous maps that Corey's group had. Sometimes there's things that were not documented, but if you have a crew with local experience, they know what to look for, and they can find those things. And so they also were experienced in conducting condition assessments for the individual assets. So moving on to the hardware, we used a Trimble subfoot receiver with an iPad. So there was the Bluetooth connectivity between the two. As I mentioned, we used collector for ArcGIS to do the field work. You see some sample screenshots on the right. Those are not actually from the iPad. They were from a different device. But we set up the questions. We also, when we set up the attributes, we also set up the appropriate domains to make the field collection a lot smoother. And they were tied into the geodetic survey VRS to get that subfoot accuracy. And of course, because we're working with collector, everything is accessing our, the hosted feature layers on ArcGIS Online. Most of the time, they were in connected mode. Every now and then, there were some areas where they had trouble with connectivity, so they got disconnected. But usually, they were connected. But overall, the field guys really like collector in the past for other projects. They've way back used ArcPad or other methods, and they say they definitely don't want to go back to that. They like the simplicity of collector, and of course, we like it because we can go straight to ArcGIS Online, and so we can do things like build a dashboard and get real time. See what's going on in real time, see how they're doing out in the field. So we developed a pretty simple dashboard just for each of the assets that we're collecting, and just some indicators to highlight the critical conditions or critical assets that they're popping up. So just a way to get a feel for how many are in like really bad shape. So they went out, they spent about, I think it was about three to 5 weeks on and off collecting the data. They collected about 2,900 assets. As you can see, most of them were smaller pipes and catch basins and drop inlets. So as they were collecting data, we do quality control back at the office. Usually that was CJ when he wasn't out in the field. Used ArcGIS Pro, tying into ArcGIS Online, accessing the feature layers. And so we reviewed the attributes, even though there were domains, and still review to make sure things make sense. Reviewing the photos, they took photos of all the assets. Make sure that photos were good quality, showed what they were supposed to, didn't have, sometimes you get glare, and sometimes the folks in the field may not realize that the photo didn't come out that well. So just checked for that. Did some snapping of features. Occasionally they had trouble with in the field with features not snapping properly. So rather than burden them in the field with worrying about snapping, and they're out there in the heat and sometimes near traffic or bad conditions. So we just CJ took that burden off them, and he just did a lot of snapping back at the office and Pro. But when you say they weren't snapped, I mean they were off by inches. It's not like they were off by several feet. So it was pretty obvious what needed to be snapped to what. So once we got everything cleaned up, we wanted a way to just generate some reports as to what was going on with the different assets. So we used the you may be familiar with the ArcGIS Online, Survey 123 report generator. So we use that. If you're not familiar with it, you can set up a template in Word, which you see on the left. It's just a sample for the junction box reports. So you can set it up in Word, format it however you want, logos, that kind of stuff, and then tell it which fields you want to pull in. And on the right, you can see an example of a final, one of the sheets for one of the assets. So we pulled in obviously a photo and a map showing the location, and then some of the condition information that they collected in the field. So it's a nice, clean way to, not just for Corey to see what was going on, but it's something that, we generated PDFs. He could distribute them to his folks. They can do site visits and just have, whether they have a printout, hard copy printout, or just take the PDF on a tablet or other device. Just gives them a way to have everything summarized for them. It worked really well. In this case, we were just dealing with one photo per report. In the past, we've had trouble when it gets more cumbersome when you have multiple attachments and you get the related tables, and trying to get all that formatted. It's a little more cumbersome, but for our purposes, here it worked pretty well. Some catch basin examples. These were, all the reports were generated, so they're like in sequential order as you go down a street. So it makes it really convenient for the folks when they go out in the field to just walk down the street, flip a page, go to the next one. So it's very convenient. Some more examples for pipes and ditches. So that's all good for an idea of where things, the current asset situation. But what we wanted to do, and Corey's group wanted to do, is do what we call a risk analysis to say, okay, we collected all this data and all these conditions. Now, what do we need to address first? So the way to do it is do a risk analysis in which you sort of rank the assets in terms of risk, how basically in terms of maintenance or potential impact in case of failure, the ones that'll have the worst impact or the greatest impact. This allows Corey and his group to prioritize for maintenance purposes. So for example, an example of a high risk asset would be something like a large pipe that's in poor, or critical condition in a high traffic area that's near a hospital. If that asset fails, you're going to have impacts, probably vehicle traffic impacts, maybe pedestrian traffic impacts. There may be impacting the access to the hospital, which obviously you don't want, or maybe some damage to hospital facilities. So the risk analysis just takes different measures into account and spits out a kind of an index. So the risk itself is, just in a general sense, it's a probability of failure, which is basically based on the asset condition, so critical all the way to very good condition, and a criticality rating, which is based on several factors such as a facility type, zoning type, street classification, flood hotspot, and asset type. So for all the assets that we collected, we assigned these different types, like facility, zoning, street class. So for example, if the asset, say it's a drop inlet, it fell on hospital property, it would get flagged as a hospital facility type. If it fell in a residential, low density residential area, it would be flagged as such. The thing that, you might think, oh, it's a simple overlay, GIS overlay operation, but in reality, what happens is, as you can see with the zoning, the zoning polygons don't go to the center line of the streets. A good number of the assets, these drains and things, are actually in the street. So if you try to intersect, it's not going to happen. And then you have situations where you might have a pipe that crosses a road. On one side of the road, it might be like commercial zoning. On the other side might be low residential, low density residential zoning. So you have to make these judgment calls sometimes. But anyway, we went through and we assigned these different values of, flooding. We had some, Corey's group had some data on flooding hotspots. So the assets were assigned whether they fell in one of those two, like the actual hotspot or the drainage area around that hotspot. And
Hi, John, can you hear
yes.
me? I'm so sorry, I hate to interrupt, but I'm going to ask you if you could maybe wrap up in the next 30 seconds. We've got a couple of questions. And again, I want to remind everybody, please send your questions through the chat. But yeah, I'll turn it back over to you. Thank you.
All right. Yeah, thanks. So we assigned those categories, and I won't go into detail, but basically there's lookup tables. So for hospital, it gets a certain, like a hospital's a high critical facility, so it gets a 5, and so forth with the flooding. And then there's weighting factors for each of those categories, the street type, the facility type. So we multiply and we sum them up, and we multiply by the condition score. So like an asset in critical condition is a 5, a very good is a 1. And we come up with something like this. The risk is on the right. This is just a subset of the different intermediate steps. But then, of course, being GIS folks, we map the results, and which is nice because, as we know from doing spatial analysis, when you map things, you can see patterns. So you can see zoomed into the downtown area, a lot of critical, high risk assets down around the Queen Church Street area of downtown. So obviously this helps Corey's group in terms of planning, assigning work orders, forecasting, developing stormwater fees, etc. And yeah, that pretty much wraps it up. There's other next steps they're going to, and I would let Corey speak, but since we're out of time, some more invasive assessments, getting a little bit deeper into the conditions and testing the different assets. But yeah, continuing to use the GIS database to manage the town system. So yeah, with that, I'll open it up for questions.
All right, thanks, John. Our first question is from Jonathan Broom. He asked, did any of this data help the town decide to allocate funds for stormwater maintenance work in Edenton?
I think Corey would be a good person to answer that. Corey?
Yeah, so we timed everything for both phases to be able to get reports and everything back for 2 different types of cost analysis. One being just your repair maintenance, were items that were what we would call critical. Those items, so we'll get these final counts in based on the asset type. We'll have an estimated cost to repair or replace each of those asset types based on the counts that we have. We'll scale that up to a total number. And so just for example, 5 assets, drop inlets may be $25,000 worth of repairs. Piping may be $100,000 worth of repairs. Pipes greater than 48, maybe, 15,000. That each of those combined did give us the opportunity as we approach the end of our fiscal year to plan and budget for what it's going to take just to repair what's there. Now, the flip side of that is we knew all the problems. We can get a budget number together for the areas that needed something done immediately. Now we can also evaluate costs to maintain those assets once they're repaired. So it did give us the opportunity to get 2 different sets of costs, one being repair costs, one being maintain costs, to be able to use for this upcoming fiscal year. And on the back side of that, we are looking at using this data also for our newly created stormwater feeds.
All right. We have another question. Were the condition assessments of the assets completed in the field or derived by data using some algorithm? And how will this data be maintained?
Okay, yeah, I'm having a little trouble hearing, but I think the question was if the assessments were based on an algorithm. No, there was the field for the overall condition assessment that was done in the field by our field crews. As I mentioned, they've been doing this kind of stuff for a long time, and so they understand how to rate, how to do condition assessments. So yeah, in this case, they were done just in the field by our field crew.
All right, and how is that data maintained?
Yeah, well, I think it's part of, Corey can jump in, but part of future efforts will be, yeah, to use this as kind of a base. And I'm not sure if you have a time frame in mind, Corey, but you're going to use this as a base for future surveys.
Yes.
And you're going to do the follow-up with the, like I said, with the more invasive testing.
Yes.
So that'll become part of the database.
Yeah, that's right. So all of that data initially will be housed in the attributes for these GIS points. Those attributes will be updated as we make improvements, and we will maintain just work order history based on whatever was corrected. And so that's how we plan to manage that. Now, what we'll do, and say we complete everything we need to do in 5 years, we may have these guys back in to reassess what was repaired, what's the condition now, so we can see improvements. So that way, when we get back around to, is it time to reconsider the stormwater fee? Have things gotten better? Have things gotten worse? Do we need to do something different on what we charge our customers? That would be the time that we would reevaluate the attributes from what they were looking back 5 years.
Right, unfortunately, everyone, we are out of time. We do have several more questions, so I want to encourage you all to please, we have John and Corey's contact information on the screen. Please take that down and feel free to email them those questions.
Definitely.
I do want to let everybody know that this session will be broadcast on our YouTube station live, so you'll have a chance to review that as well. And again, I want to thank you, John and Corey, a lot of good information, and thank you again for your presentation. And thanks everybody for coming in.
Thank you. Bye-bye.
Bye-bye.